Hello, this is the third video about the world of computers, and the purpose of these videos is to teach you some very basics of how computers operate. In earlier videos we have studied the binary numbers, and we have studied how computer memories work and how those binary numbers are stored in computer memories. And this time we are going to start studying the real thing. We are going to start studying how computers operate. And we are going to do this by studying an imaginary computer and a simulator called IC8. So you may ask that why are we studying an imaginary computer and not a real computer? And the reason for this is that the real computers, they are so complicated that it's not going to be possible to explain their operation in a single lesson. And this imaginary computer that we are going to study, that is so simple, and and with that it should be quite easy to learn the very basics of how computers work. So that is the reason why we are going to use an imaginary computer here. And what we are going to study today is that we are going to study what are machine instructions and how these instructions are fetched and executed by the computer. And we are also going to really study a real computer program. So I'm speaking about this simulator IC8, and that is just one internet page that is actually a computer program that simulates the imaginary computer. And you can find the simulator if you first go to my site naturalprogramming.com. And then if you choose this icon IC8, you will find this page. And this page contains some instructions and even some exercises. And here is a link to the actual simulator. And if you click this link, you will find this page. And this is now the simulator. And it is really a JavaScript program that is running inside the browser. So if I reload this page, it will show some texts, and then the computer is ready to be used. And this is now a simulator, so that it simulates the computer, or it behaves like if the computer would be built by using real electronic components. But this computer hasn't been built as a physical computer, and it's not wise to do so. So for that reason it is called an imaginary computer. Its name is the name of the simulator is IC8. So IC means the imaginary computer, and 8 means that it has an 8-bit architecture. And well, this imaginary computer, it has some parts. So here on the right there is the main memory. On the right there is the main memory, and all this area here, it is the processor, and then there is also a small kind of keyboard here, and there is also a screen. So it is a very simple computer with a keyboard and a screen and a processor and memory. And these yellow lines here, they are we can call them buses which contain imaginary wires for the binary information to move from one place to another place. And these buttons here, there are buttons: load button, execute button, reset button, translate button, and modify button. And there are some numerical buttons here. So we will learn to use these buttons during these lessons. And these numerical buttons here, that with this we can select that in what way the information is displayed by this computer. So now it is using the hexadecimal numbering system. But if I press this 10 button here, it uses the decimal system, and if I press this button with the label 2, it uses the binary system. But as we have learned, it is the hexadecimal system is quite useful in the world of computers, and so we are going to use these hexadecimal numbers here. So these hexadecimal numbers, they may look a little bit odd at the beginning, but well, you should get used to them. I think it's one important thing what we should take a look at first is this main memory. So this part on the right is the main memory, and you can see that all memory locations contain the value FF, which means that all bits are set to 1 there. So all the values are FF, and so the main memory doesn't contain any meaningful information at the beginning. And it's important to note also that all these memory locations, so we can call them memory locations, these bytes of memory. So all these memory locations, they have also addresses. So the address of the first location is 00, address of the second location is 01, address of the third location is 02, address of the fourth location is 03, and so on. So all memory locations, they have addresses, and we can see here memory location, we can see altogether 18, we can see a little bit more than 18 memory locations here. So 17 is the address of the last location that we can see. There is actually 256 bytes of memory in this computer. And actually we can, if I press this modify button, I can see the whole memory. So these are the memory ranges, and if I press this button here, you can see that now it is showing the last bytes of the memory. But if I press this again, it's showing the first bytes. So this computer has altogether 256 bytes of main memory. It's not much, but we will see that with this small amount of memory we can do some very basic computing operations. And it's important to understand that, as I have already shown you pictures like this in earlier videos. I have shown these pictures like this, that you can think of the main memory of a computer like a long list of bytes, and each byte can store then 8 bits of information. So it means that each memory location can store numbers from 0 to 255. So in the imaginary computer we have only 256 bytes of main memory, but in your own computer, if you have something like 8 gigabytes of memory, it means that you have 8,000 million, more than 8,000 million bytes in your computer. But the principle is the same, that you can think of the main memory as a long list of bytes. And in this imaginary computer, it is somewhat shorter list of bytes. So each memory location in the main memory can store 1 byte or 8 bits of information. And then I have this dark or dark gray things here, so they are called registers. So there is register A, register B, register for instruction code, register for operand. Then there is the input port. This is also register. There is output port. Then there is a register named program pointer, memory pointer, stack pointer, and there is this memory switch also. And then there is also this address control register. And these registers are also kind of memory locations that they can store 1 byte of information. And we will see that the computer is moving information, can move information, the binary or numerical information between these registers, and it can do some calculations. And so we have the screen here, and we have the keyboard. And this large rounded rectangle here is then, we can think that is the intelligence of this processor. So that contains the intelligence, and in real computers it is made with the electronics circuitry, but here we can just think that contains the intelligence of the machine. So and these yellow things here, we will see that information is going to flow inside these yellow things, and they are usually called buses. So, and this computer actually it is a little bit like real computer, so that it has pre-built applications or programs inside the computer. So what I'm going to do now, I'm going to load a program into the main memory. And there is this load button here. I'm going to use this. So I get the list of programs that are available, and I select the first program that is called hello.iml. There is a reason why there is this ending .iml, but I will explain that later. So I'm going to load this program, and you saw that now the content of the main memory changed. The contents of the main memory changed, so now the program is at the beginning of the main memory. And you can see these things like 154892 16659215. So these are now the so-called machine instructions. They are machine instructions, and the processor of the computer we can think that the processor can understand these machine instructions. And so, for instance, the first, you can see that the code 15, it is repeated here, and also the code 92 are repeated here. So they are the instruction codes for the machine instructions. So, for instance, at the beginning, you will find, at the beginning of the program, you will find these values. 15 and 48. So this is the code for instruction and this is the operand for the instruction. And then there is this another value 92, that is also the code for the instruction. So you can think that the imaginary processor of the computer, it can understand these codes. And this code, we will see that this code is, for instance, this code means to the processor, the meaning for the processor is that load register A with value. And this other code 92 is output register A. But when we start using the processor or the computer, we will see that it can tell this what it is doing. So let's start executing the program. So we will start executing the program. So I press the execute button, and you can see that I can always stop the computer anytime I wish. So what is started doing, it says that it's fetching instruction code. So I press the continue button. It does a reading operation from memory. And what it did, it copied from the memory location, from the first memory location, it copied this value to this register instruction code. So it did fetch from the main memory the instruction code. And then after that, it incremented the value of this register program pointer. So this program pointer is a register that specifies from where in the main memory the next instruction should be fetched. So at the beginning it was 0, so the first instruction was taken from location 0, 0. But now the next operation will take a value from the location with address 0, 1. So we have to then I have to tell one essential thing, that there are two kinds of instructions in this computer. So there are 2-byte instructions and single byte instructions. And those 2-byte instructions are such that their instruction code is odd, which means that when the code of the instruction is odd, it fetches an operand for the instruction. And in this case the code is odd, so 15 is an odd number, so it is going to fetch another byte from the memory. So I will press the continue button here. It says that fetching operand, and now it takes the second value from the memory and it copies it to the register operand. And again, it incremented this program pointer here. So now the instruction has been fetched from the memory. And now the processor starts executing the instruction. And this, we will see it soon what it does. copying 48 to register A. So what it did, it copied this value that came as an operand, it copied it to the register A. And so that was the that was the end of execution, and it again says that fetching instruction code. So now it is going to fetch the next instruction from the address 02. So it's going to fetch this instruction in this address. I press the continue button. And now you can see that it copied the value from this address, the value 92, to the instruction code register. And what is important here to notice also that the previous content of this register is now lost. So the previous content was 15, but now it is written over. So these registers work also always so that they keep their content while this computer is running, but when something new is written to a register, then the previous content is lost. And now the meaning of this instruction 9.2 is that output register A. So let's see what happens. So it says outputting byte 48 code of H. So this value from register A was copied to this output port, and this output port works so that always when something is written to the output port, the character that corresponds to this value is displayed to the screen. And now, because we in earlier video we saw this table of character codes, and we can see here that this code 48, it is the code of uppercase letter H. So for that reason it did show the letter H on the imaginary screen. So it starts fetching the next instruction, and now it takes an instruction from location with address 003, and it copies it to instruction code register, and it is an odd instruction, so it fetches an operand, and it copies the operand value from memory to location out of the operand register, like that. So it was actually the same instruction that was at the beginning. So you can see that there is this the same instruction was at the beginning of the program, and now the same instruction is here again, but with a different operand. And now it executes the instruction, and it simply copies the value from the operand register to register A. And now it starts fetching the next instruction from location 05, and again it gets the instruction 92, and now it prints the value E to the screen, because 65 is the character code of lowercase e, and again it fetches a new instruction from the main memory, and it sees that it needs an operand. It fetches an operand, and now it copies new value to register A, and again it fetches a new instruction code, and so the execution of the program continues like this. So I can actually, what I can do here, I have this kind of LEDs here. With this I can regulate the speed of the imaginary computer. So if I press this LED here, it starts working a little bit quicker, and the execution of the program happens quickly. So now the execution of the program is terminated. And what this program did, it printed the text hello with the exclamation mark to the screen. So, so this was the first program for the imaginary computer for you to see. And what is important here, that this program, I can actually write it down. I can actually write it down. So the program is actually this. So there was the first code 154892156592 and 156C92 and 156C92. And this continues, and at the end of the program there is this instruction B2. So the program looks like this, and it's important to know that this instruction is repeated. This 15 instruction is repeated many times. So it means that there are the same instructions are repeated over and over in this program, and so this always means that this value is loaded to the register A, and then this means that the value is output to the screen, and this value is loaded to register A, and this value means that the value is output to the screen. So this is it repeats these three instructions or the 3 bytes. Or actually it repeats these 2 instructions with a different operand over and over again. And this way we can print each character of the text. And so now we know that what is a computer program. So the computer program is this list of bytes. So that is the computer program here, and well, when we put a different kind of computer program into the main memory, the computer works in a different way. And then there is also important to know that there is this special instruction B2, and that is not available in real computers, so that makes the processor stop. So real computers don't have this kind of instruction, but this is an educational computer, so this has this kind of instruction. So I think this was our first look at the imaginary computer and its programs, its machine instructions. So this is actually, this whole computer, it is explained in my computer programming books. So if you want to read about this on paper, you will find, if you go, for instance, if you go to the main page of naturalprogramming.com, and then if you go to this Java page, and there if you select this table of contents and sample pages, so here you can find the chapter how computers operate. So there is a full chapter of this book available there, and that there is a lot of text that explains how this imaginary computer works. But we are going to continue studying this imaginary computer in future videos, and so it may not be necessary to read that book, or the pages of the book, but it doesn't harm you anything if you do read that. And well, let's put the computer in full speed so you can see that it does this with maximum speed. So it's possible to re-execute the program as many times you like. But I think this was the first lesson about the imaginary computer, and I will explain more things in the following videos. So I thank you for your attention, and goodbye.